This video is over solving radical inequalities, and to do this we can use a table or a graph, but we really don't want to do this algebraically. We want to actually do this visually so that we can see clearly what the answers are going to be. And I'm only going to do two examples. The first one we're going to use a table. So if we use a table to solve 3 square root x minus 1 is less than or equal to 11. If we were to try it with algebra, we would first want to add 1 to both sides, and we would have 3 square root x is less than or equal to 12, and then we would divide both sides by 3. The square root of x is less than or equal to 4, and then we would square both sides. X is less than or equal to 16. And that would be partially true. X is less than or equal to 16. But there's also the limitation of that square root there. We can't take the square root of negative numbers. So we also know that x has to be greater than or equal to 0. And it's easier to just do this in a table or a graph and look at it and see that rather than have to be burdened with remembering it. So if I say use a table, just go in your calculator and punch it into y equals. You can go ahead and put the left side and the right side each in their own. So 3 square root of x minus 1 can go in y1 and 11 can go in y2. And then hit second table to look at the table. And we're going to scroll around in that table and look for all the values of y here in this column that are less than or equal to 11 in this column. So if you can tell, all of these are all less than 11. So if you scroll backwards, you'll see this. And if you scroll the other way on x, you'll see this. And what this tells you is when you look here, when the x goes down to 0, after 0, y is an error. So we know that it only works starting at 0. And then when you look down here, you see that it does, at 16, it does actually equal 11. So all of these are less than 11, and then 16 is the end. And so, since what we're looking for is where does 3 square root x minus 1, where is that less than 11? That's what's in our y column. That's these things. Where is that less than 11? That'd be everywhere from here on up to here, right? Less than or equal to, so this does count, sorry. So that would correspond to all of these x's that are between 0 and 16. So we would say 0 is less than or equal to x is less than or equal to 16. And that's how you'll give me your answer. You could also put it in set notation and tell me that x equals everything from 0 to 16 inclusive. You can put it like that. And if the instructions say use a table, then you need to show me, just write down some of the table on the paper, showing me what you saw here in your calculator that gave you that answer. Okay, this next example says use a graph to solve the square root of x minus 5 is greater than 3. So I'm going to put that in y1, and I'm going to put that in y2, and then I'm going to look at the graph. And here's what it looks like in the calculator. But in this standard window, I can't see where the two intersect. See, this curve is the square root of x minus 5. You can see it's shifted right 5 units. And this line is y equals 3. And we want to know where they equal each other, so we're going to have to extend the x max in our window. And then when you do that, it would look like this. I extended mine out to x is 30, but I think 20 would probably be sufficient because you can see that the intersection happens right here. So you're going to go second calc intersect, enter, 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 and you will find that intersection. And it will give you that the answer there is 14. So this is 14 right here. But the thing is, we want to know where is it greater than 3. And greater than just means up. Where is it above 3? So all of this and then going on forever, right? So that means that, that corresponds to all x values that are on the right-hand side, so greater than, not equal to because we didn't have equal to in our problem, but greater than 14. X is greater than 14 is all we have. If we'd have been looking at the bottom part of it, then we would have a bottom and a top. But since this time we're looking at the part that keeps going, we just have one ended. And that's it. That's all there is to the inequalities. And that's the end of my video for today. Short and sweet. Good night.